Hello IB and A-level students, welcome to Key Skill 4 where I'm going to show you how you can solve equations that have modulus bars in them, like this example here. First of all, we're going to kind of think about what the graph looks like to get some context. I have a little trick for graphing these and I'm going to share that with you. I do it in the same way as I graph using the minimum point for completing the square. So what that means is I take inside the brackets and I make that equal to 0 to get the x coordinate of the minimum point. So in this case here, that's going to be -2. And then whatever's outside is my y coordinate. So that means here that my minimum point is going to be -2, 3. So I've marked that here on my graph. Now you can see this is in the same format as a y equals mx plus c graph. It has gradient 1. So you could then spiral out using gradient 1, along by 1, up by 1, or what I'm going to do is I'm going to find the y-intercept. So in this case here, my y-intercept is going to happen when x is equal to 0. Absolute value of 2 is just 2, so 2 minus 3, so y equals -1. And then that's going to give me 2 points, so I can start my V-shaped graph here. Okay, and I'm going to follow the pattern over here. So this is going to be 2 and 2, so this is going to be also 2 and 2 to get that perfect reflection, because remember, my line of reflection is the line x equals to -2, as this is my minimum point. So pretty similar technique altogether that I use for completing the square, to graph from completed square. And my second equation is going to be y equals to 4. So you can imagine this graph here kept going. You're actually going to get two solutions where these two graphs intersect, both here and here. And I'm going to show you now algebraically how you can find both of them. But I just wanted to visualize why you would have 2 points of intersection. What you do is you split your page in half like this, and on the first half here, you take your function, which is in this case x plus 2 minus 3 equals to 4. You put everything that's not inside the absolute value symbols on one side, like this, so I'd have 4 add 3, and I've got absolute value of x plus 2 equals to 7. Now, on this side, I'm just going to solve x plus 2 equals to 7. And on the other side, I'm going to solve x plus 2 equals to, or minus x plus 2 equals to 7. And the idea is if I remove the absolute value, inside the bracket, I could have had two options. For example, I can have -3 is equal to 3, and I can have +3 is equal to 3. So I have to consider both options. Inside the bracket was a positive number, or +1 times that, whatever's inside the bracket, or inside the bracket was originally a minus number. And that's going to get me the two solutions. So in this case, I have x plus 2 equals 7, x should equal to -2 minus 2, x should equal to 5. And here I'm going to multiply in the -1, so it's minus x minus 2 equals to 7. I'm going to add 2 to both sides. So that's going to give me minus x equals to 9 and x equals to -9. And we can have a little look at what those graphs look like. So this is the graph that we discussed previously. You can see it's got its minimum point, which I find really useful to graph from, at -2 minus 3, and it's got its y-intercept here at 0 minus 1. You could also just take a couple of other points if you wanted to get a second point on this stretch here. Now, what I did then is I intercepted it with the line y equals to 4 here, and you can see here, if I zoom out a little bit, there are exactly 2 points of intersection. We've got 1 point over here, which is when x is equal to 5, and we've got 1 point over here when x is equal to -9. And we got those two by opening the brackets, removing the modular symbol twice, once assuming that inside the bracket had originally been positive, and once assuming inside the bracket had originally been negative, and that will get you both values for x. Guys, if you have any requests for videos, post them in the comments below. I'm always wondering what students want me to make next. I hope you've enjoyed this series. I know my Year 12 class were really confused by the modular symbol, so I definitely wanted to make this for them. Goodbye everyone, and happy studying.